not get distracted by your phone, okay? So I'll switch the dot cam now. So a couple of things. My email is on page 2. So it's tinaresp@hotmail.com. So again, you can email me any questions anytime. And the formulas that I kind of, think you should memorize are in the front of the book, but they're also in your account. So there's a printable copy in there. So you can print that out if you prefer it and, study all those formulas. I would kind of get studying them now because there is a lot. As far as the supplement goes, it's split into 2. So if you did pick up like a physical copy of the booklet, then you got kind of half of them in one and the other half are online. If you're just taking your own notes, like annotating or in a notebook or something, then just make sure you see there's 2 supplements in your account, not just one, okay? So the solutions are here. So you can see there are lots of finals, midterm 2s and midterm 1s. So this course often used to have 2 midterms. So the midterm 2s, there's lots of good questions there to try as well. And again, I just kind of put a little note, no 3x3 inverses, 3x3 determinants, no dot or cross. This would include like no 3x3 eigenvectors, I guess is the hard part, right? So everything's kind of more 2x2 oriented this year. Okay, so in terms of the table of contents, if you go back to page 1, then the on-demand video should already be in your account. Let me know if you have any trouble. And so it covers all the midterm material. So from A all the way up to, we kind of covered, basic and conditional probability. This was a bit of a strange year because we didn't cover the very end of probability on your first test, your midterm this year. So things like type 1 and 2 errors and specificity and sensitivity, they didn't quite get to. So that is normally on the midterm. So I just kind of called it O because it's, generally midterm material kind of thing. So that's where we'll start, and then we'll be continuing on here tonight and tomorrow. So same time tomorrow night, 5 o'clock on Zoom again, okay? Okay, so turn to section O. It's on page 161. And again, for anyone coming in, you can just post any questions on the Q&A, okay? So page 161. Okay, so we define the sensitivity as the probability that the test is positive given that you have the disease. The specificity is that the test is negative given that you don't have this particular disease, okay? And, at the midterm, we talked about drawing trees and all the different things from that. So we're just going to kind of take off from there. So a particular type of cancer has an incidence rate in London of 1%. Okay, the sensitivity of the test is 0.9. Okay, so this is 0.9 in this question. And the specificity here is 0.8. Okay, so if we want to draw a tree, a lot of people are visual, so it kind of helps them. We can say they have the disease or they don't. Having the disease, so that is 1%. So if 1% has the disease, then 99% don't. And then our conditionals are all our second branches. So we can either test positive or test negative, given we have the disease, or we can test positive or test negative, given that we don't actually have the disease. So remember, sensitivity, test positive given have the disease. So that's right here, right? This spot is a given, right? It's this given what's in front. So that's that probability. And then down here, we have test negative given don't have the disease is 0.8. So remember, with probabilities, branches add to 1. So that's 1%, 99. So 0.9 would be 0.1. Those sets of branches add to 1. And here we'd have a 0.2. So what does the question ask us to do here? Well, let's take a look. Find the probability a randomly selected person doesn't have the disease given they had a negative test. Okay, so don't have the disease given a negative test. Remember, the given part is the part that goes after the slash, right? And the one we want to find goes first. So we're given they had a negative test. I usually just say T negative for negative test. And we want to know, find the probability that they don't have the disease. So that is D negative. So if we use our conditional formula from your midterm, A given B, probability of A given B is A and B over B. So this one would be D negative and T negative all over the given one, that the test is negative. And in order to actually work out the numbers, they have to make them, pretty good on the final, right? Because of the fact that they took your calculators away. So negative disease and test negative. So that's here. So we would say, remember, and is to multiply through our tree. So 0.99 times 0.8. On the bottom, if we want the test to be negative, we can be here or here. Anything that occurs at the far right, we have to multiply through to get to it, right? So we could test negative and have the disease, so D plus and T minus, or we could not have the disease and test negative. So there's two ways to test negative. So we multiply through 0.01 times 0.1, or add 0.99 times 0.8. This is D plus and T minus, and then this one is D minus and T minus. Okay. And then the next thing that you guys talked about at, just right after your midterm you finished it, was type 1 and 2 errors, right? So a type 1 error is when we conclude that the condition is present when it really isn't. So it's what we call a false positive, a type 1 error, okay? So they tell you you have a disease, but really you don't in reality. And it's equal to 1 minus your specificity. The type 2 error is like what we call a false negative, right? So in this case, it's 1 minus the sensitivity, and a false negative is, so this one, false positive is they tell you you have the disease, and really you don't. And this one, we conclude that the condition is not present, but really it is, right? So here, they tell you that you don't have it, but the reality is that you do. And hopefully some of you guys will perfect some of these tests because they're both awful. Getting a false positive or a false negative. I had a student once in first year, and she was told that she would be dead of a brain tumor the next semester. And then when I saw her a few months later, it was obviously horrible. And I saw her a few months later, and she was like, oh, it's amazing. Like, it was a false positive. Like, they told me I had this particular type of brain tumor and I wasn't going to make it. And then she was fine. That's obviously much better because she lived and she didn't have it. But then I also, have a friend, false negative. Her dad was told that he didn't have cancer and he was going to be fine. He was dead 2 months later, and they found cancer throughout his body, right? So obviously, these tests are not perfect and not fun when it's not right, okay? So this one, 100 patients are tested for COVID. 40 of them had COVID. Of the 50 that tested positive, 28 had COVID. Find the sensitivity, specificity, and the probabilities of type 1 and 2 errors. So I kind of try to draw a picture for you here for the 100 people. So I said E was had COVID. So this side is had COVID. E complement is people that didn't have COVID. So we know here that 40 people had it and 60 didn't, right? 100 minus 40 that had it, obviously 60 that did not. And then it says of the 50 that tested positive, 28 actually had COVID. So these are the ones that tested positive, right? That was 50 people. So if we take away the 28 that had it, that leaves 22 on this side that didn't have it, but also tested positive. And then if we take 60 minus 22, then of these people that didn't have COVID, well, 60 minus 22 leaves 38 that tested negative and didn't have it, right? The 22 is tested positive. So sensitivity, well, that's probably the test is positive given they have the disease. So if we take a look here, test positive and have the disease. Test positive and have the disease. Well, that's over here, right? 28 people out of 100. that had COVID and tested positive. On the bottom, we have the probability that they have the disease. And they told us in the question it was 40 of them. So the hundreds really cancel, because if we divide fractions, we can multiply by the reciprocal of this one. And so the hundreds will cancel out and we just get 28 out of 40. Or we could divide by 4 and say 7/10. Some people like decimals, some like fractions. So, you'll have to take a look at the exam and see which way they give the answers. So then a type 2 error is just 1 minus whatever this sensitivity is. So that would be equal to 0.3. Okay? So that's sensitivity and probability of a type 2 error. Specificity is that we have a test that's negative given we don't have it. So if we look at our information, the negative test and don't have it. So over here is don't have COVID. That's the positive test. So the negative test was those 38 people. So 38 over 100. And then don't have the disease. Well, it was 60, right? 40 had it. So 100 minus 40 is 60 that didn't. Again, we can divide the fractions, multiply with the reciprocal, cancel the hundreds. So 38 over 60 or 19 over 30. So if we did need the decimal for that, then we'd have to use long division, right? We'd have to divide, 30 into 19. So it just depends on how they give it. If we had to do it, I would just do, 6 times 3 is 18. So 6 times 30 would be 180. Subtract 190, take away 180 is 10. Bring down my 0. 30 into 100 would be 3 times, because 3 times 30 would be 90. And then, if we brought down another 0, it would just be 0.3, right? 63.3%, in other words. Okay. So the probability of a type 1 error would be 1 minus our specificity. And if we want fractions, just 1 minus 19 over 30. So we could just say common denominator of 30. So 30 over 30 minus 19 over 30 would be 11 over 30. If we wanted the decimal, we could just do 1 minus 0.63. 0.37, approximately, right? I'm not sure how many decimals they would keep. It just depends on the prof making the exam. Okay, so the last one is a pretty tricky one. It's a question that they gave multiple parts to off a midterm, I believe it was last year. And it was tough. A lot of people didn't do well on the long answer for this question. So it is definitely a harder style of question. Some of the parts, at least. So they gave them that a population has 1,000 people and the prevalence of cancer is 0.001. Then they told them the sensitivity is 0.9, the specificity is 0.95. So I drew your tree. So have the disease, 0.001. So don't have, 1 minus that, 0.999. Test positive or test negative from each of these. And so here, test positive given that they have the disease, that's 0.9. So that's right there. So that has to add to 1. So that's 0.1. And then down at the bottom here, test negative given don't have the disease, the specificity is there, 0.95. So those add to 1. So A said, different numbers, of course, but this style of question, in part A, they asked the number of people who have the disease in the population. So if there's 1,000 people in the population, then the number that have the disease is just the number times the probability of having the disease. So it would be 1,000 times 0.001, which means 10 people who have this particular disease. If we want to know how many don't have it then, which we'll need in a further question, then really it's 990, right, who don't have the disease. Okay. So you didn't need that for part A. This would be the answer for part A, but this we're going to need shortly in the next one. So B, what's the probability of a false positive and the number of false positives? So probability of false positive, number of false positives. So a false positive means 1, 2, 3. Oh, maybe it's supposed to be, is it supposed to be 10,000 people? Did I write the wrong number? 10,000. Okay, thank you. 10,000 people. Got it. Yes. Okay, so that would be, yeah, that's right. Yeah, sorry. Yeah, I must have just had the wrong decimal there. Maybe I should just keep it as 1,000, just say 0.01. Yeah, let me do that. I'll just say 0.01 then. That's probably easier, right? Yeah, thank you. Sorry about that. Yeah, let's not change the number there. That will just make it more confusing, I think. Thanks. Okay, so the probability of a false positive, well, we would have to say that it tells us we have the disease, but we don't. So where is that on your picture? That would be right here, right? Test positive given don't have the disease. So 0.05. So how many then would have a false positive? How many people? Well, if we say there's 0.05 times 1,000 people, then that's 0.05 times 1,000. But look, it's not 1,000. Up here it was 1,000 because it was the number of people in the population who had it. But look, this is the number of false positives. Well, we have 990 people here who don't have it. So we have to be careful. This is only times 990. N is the number without the disease. So guess what? People got that wrong, right? They did 0.05 times 1,000, which was the trick. So here we've just got 0.05 times 990. So that's basically, well, I guess you can't have half a person, so 50 people, but anyway, 49.5 is the exact answer. And then what is the probability of a false negative and the number of false negatives? Well, the probability of a false negative is what? Well, look at your numbers. What's the probability of a false negative here, guys? Look at your tree. What would it be? False negative. Well, in other words, test negative given you have it, right? So if we have the disease, here is test negative given we have it. So that's 0.1. So what would be the number of false negatives? Well, the number of false negatives is 0.1, our decimal times n. N here is the number with the disease, right? Up here, it was the number without, but down here, number of false negatives, so we have to do times the number with the disease. And that was what, 10 people from A. So 0.1 times 10 would be 1 person. Okay, and then D, we're gonna have to flip back and forth. The number of true positives and true negatives. True positives and true negatives. Okay, well, if we want the probability of a true positive, that means you test positive given that you have it, right? Which, look at your tree. We've got 0.9, test positive given you have it. So what's your number of true positives then? Well, it'll be 0.9 times those 10 people, which is going to be 9. And then we have probability of a true negative. Well, where's a true negative? Test negative down here, given we don't have it. So that's 0.95. So the number of true negatives is 0.95 times those 990 people. Now, if you think about, all the totals, you know that it has to add up to the 1,000 people, right? So if you think about, we had the 49.5 was the false positive, and then we had one person was the false negative. So then if we have, the true positive, that was 9, and then the 940.5 is the true negatives, and that's our 1,000 people. So instead of doing, some of the multiplying like of this one, you could just subtract from the total as well. Now, the last part asks them something similar to this. If an individual in the population is tested for the disease, and the test comes back positive, is it more likely they actually have the disease or that the test is wrong? Okay, think logically about that. Is it more likely that they actually have it or that the test screwed up? Any ideas? Based on our numbers in BCD? Well, of these 1,000 people, we had this many got a false positive and this many got a true positive. So if you're someone who they told has the disease, 49.5 people got a false positive, only 9 got a true positive. So it is more likely that they screwed up the test and that you don't have the disease, right? So more likely the test is wrong than that they actually have the disease. Okay, so that was, basically the portion of the usual midterm material that you didn't cover in time, okay? So that material, though, will be on all the practice midterms, right? So make sure and, do at least a few midterms before you get into the final material from the supplement, just to practice it. It's also always a good idea to redo your own midterm. Although your midterm, I know, was really easy this term, people said. It was pretty straightforward. So, definitely want to try some of the other midterms as well. So whether your final is going to be brutal because of your midterm average being high and it being so easy is hard to say. Most times, I think there's only been 1 or 2 times in, almost 20 years that they've said the midterm was good, the final was good, ever. So usually it is really tough. But again, there's different people doing the course, so you never know, right? You could get lucky, just don't count on it. Okay. So flip to, what I called section A, so sort of the post-midterm material. So 166. Okay, so discrete random variables, for the most part, is what we were covering, under the midterm, right? So things like rolling a die, flipping a coin, those are discrete random variables, right? We can only roll on a die, we can only get a 1, 2, 3, 4, 5, or 6, right? There's no way to get, it's got to be 1 to 6. I can't roll a 2.6 or 3.05 or anything like that, right? But if it's a continuous random variable, then it's not discrete, and we can have the variable take on infinitely many different possible values. So under a continuous random variable, the probability is going to be the area under your graph. So whether it be looking like a uniform graph where it's a rectangle, or whether it be a triangle, whether it be the normal distribution, any of those things, those are all continuous. Okay? So we talked about some basic probability under the midterm. We knew, how to find, some really easy probabilities using discrete. So now we're going to talk about things like the mean, the standard deviation, all those sorts of things now. So if it's discrete, we know that, first of all, probabilities can't be negative, right? They can only be between 0 and 1. And the sum of all your probabilities always has to add up to 1. Okay? So every experiment, the total probability is 1. Now, the PMF, that they're calling it this term, or probability mass function, is a non-negative function, little fx of x, which has the sum of 1, of course, and probabilities between 0 and 1. So PMF, called the probability distribution function, is what a lot of people will call it. They'll call it PDF. The problem is PDF can also stand for probability density function for continuous. So PMF, it kind of makes your life a little easier to call it probability mass function. And then you can know that, okay, we're talking about discrete. The cumulative distribution function, or CDF, is a capital F. So I know they're both F's, it's annoying, but that's the way it is. So capital Fx of x is the probabilities that you add up as you go down your table. So it's equal to all the probabilities up to and including this x. Okay, so if you roll a die, let random variable x be the number on the up face, the number that you see when you roll it. What is fx of 2? This is just standing for the probability that you got a 2. Well, the probability to roll a 2 is 1, 2 out of 6 numbers on the die. So this notation is just the probability x is 2. Okay. Suppose we have a discrete random variable, and the random variable takes on values 0, 1, 2, which the following could be a valid PMF, so probability mass function for the x. So if these are the different x values, 0, 1, 2, and these are the probabilities, so in other words, this is, the probability that x is 0 is 1. The probability x is 2 is 2. Well, this doesn't make any sense because these probabilities add up to more than 1. So that's not right. Right? 1 plus a half plus 2 is not 1. Too big. Second one. So this one is a negative. That's saying to you that the probability that x is 0 is a negative number. That doesn't make any sense, right? Probabilities can never be negative. The smallest they can be is 0. Okay? So third one. A quarter, an eighth, and 5/8. Well, if we convert them all over to 8, this would be 2/8, that's 1/8, that's 5/8. 5, 6, 7, 8. So that's 1, and they're all non-negative. So yes, right? That would be a probability mass function. Okay, questions? Okay, so let x be a discrete random variable that takes on the values 1, 2, 3. So if here's our values of x, 1, 2, 3, and here's probabilities. So little fx of x. So the probability that x is 1 is 1/5. The probability that x is 2 is 1/10. And I don't know the probability of 3. But I do know that probabilities have to add up to 1 in any experiment. Yeah. So I was just checking to be a probability mass function. I need to know that all my probabilities are between 0 and 1, right? There's nothing negative here, which they are. And I need to make sure that the total probability is the total area, which is 1. Yeah, that's right. So if there's a probability missing from your chart or from your values, just do 1 minus the rest. So I just did 1 minus a fifth minus a tenth. 1 is like 10 over 10, common denominator, so times 2 minus 2 over 10 minus 1 over 10 is 7/10. So that would be my value here. So I'm going to write this as tenths just so that they're all common denominator. So if we want a graph of the probability mass function, then we're just graphing the x values with the corresponding probabilities. So we need 1, 2, 3. For 1, we have to go up to 2/10, which is right there. For 2, we have 1/10 right there. And for 3, we go up to 7/10. So that's our x and that's our probabilities. If we want to accumulate our values here, then we've got to add them up as we go down our chart. So if you take a look here, I put it in for you. The first number, well, there's nothing to accumulate because there's nothing before it. So it just gets copied down. But after that, I have to add the next number. So here I take my 2/10 and I add the next 1/10 and I get 3/10. Then I take the 3/10 and add the next number, which is 7/10, and I get 1. So these values are the cumulatives. So remember, capital F means cumulative, which means add them up as you go down your chart. So fx of 1, cumulative at 1 would be 2/10 or 1/5. Cumulative at 2, right, f of 2 or capital Fx of 2 is 3/10. Fx of 3 is 1. If we only go up to 1, if we only go up to 3 for x values, our probability of the last one has to be 1 every single time. Because think about it, if we're adding up the probabilities, what's the total probability have to be? Well, in every experiment, the total probability has to be 1. Okay, so keep in mind, that's the case for every cumulative. So when you go to draw a cumulative, we still need x is 1, but x is 1 is at 2/10. So here, we have no probabilities before, so you can draw in, to 0. At 1, it's at 1/5, which is 2/10. And then here, at 2, the probability has to add up to 3/10. So we've got to go up to 3/10. And then at 3, we've got to go up to 1, okay? So those are our cumulatives. Now, whether or not you'll have to draw a graph, I mean, I guess they could make it a long answer. I've never seen them do it, but I mean, they can probably do whatever they want, right? So anything's possible. If you want to find a probability based on any cumulative, any probability like x equals 3, the probability of x equals 3, if you don't know it, you can always take the cumulative at 3 minus the cumulative of the one before it. That will always give you, the answer to a probability. So probability x is 2 would be f of 2 minus f of 1. So it's always taking away the one before it. Okay? So that's a formula there that you should memorize. So in our chart, f of 3 was 1, f of 2 was 3/10. So what's 1 minus 3/10? Well, it's 7/10, right? Which is the probability of 3. Now, how do we convert from a PMF to a CDF? Well, if we want to convert here, then, if we want fx of 2, that means, by definition, the probability of everything up to and including 2. Okay, so that's what we have to add up to get the cumulative up to 2. If we have a cumulative here, then we can get a probability by just doing, probability of x is 4 would be f of 4 minus f of 3. And that will work for all of them. Okay, so that's, kind of how we can work from parts of the chart to other parts. Now, what about the mean? Well, the mean of a discrete random variable, it's not like a mean where, if you have 5 marks and you want to know your average, you add up the 5 marks and divide by 5. A mean, in the case of a discrete random variable, is like the expected value, right? What do we expect in the long run? And it's going to be either mu or e of x are the symbols, and it's going to be the sum of each of the x's times the probabilities, okay? So we can write it x times probability of x. We can write it as xi times little fx of xi, right? And this, is of course the sigma or the sum symbol. So it's the sum of all the possible values of x times by, multiplied by their corresponding probabilities. Okay, so x's times probabilities. So if I give you an example here, roll an ordinary die. A game is constructed so that you win $2 if you roll an even, lose $2 if you roll a 1 or a 3, and win $4 if you roll a 5. You pay $1 to play the game. What is your net expected winnings? Okay, so draw a table, x, probability of x. So this is like, you can say xi and same thing. So your X values are what can you get? Well, it says I can win, this is winnings, so I can win $2, but I also have to pay $1 to play. So if I want to think about my net winnings, then I really can't win $2 because I had to pay $1, so I'm really only ahead $1. When does that occur? Well, that's an even number. So on a dice, that's a 2, a 4, or a 6. So what's the probability of rolling 2, 4, or 6? That's 3 cases out of 6, right? Now it says I lose $2 if I roll a 1 or a 3. So that's a drag because I lose $2 plus I had to pay $1 to play. So I'm actually 3 in the hole. And that's rolling a 1 or a 3 is 2 cases out of 6. And the last one is I win $4, but I paid $1. So I'm ahead $3 if I roll a 5. Make sure your probabilities obviously add up to 1. So what's my expected winnings? Well, sum of xi times f of xi, or x times probabilities. So basically just take your chart and multiply this times this, this times this, this times this, and add them up. So your E of x, or your mu, is 1 times 3 out of 6, plus, or we can just say minus 3 plus negative 3, same thing, times 2 over 6, plus 3 times 1 over 6. So that's 3 minus 6 plus 3, all over 6, which is nothing. If you expect to win nothing, you expect to lose nothing, it's considered what we call a fair game. Okay, a fair game. Okay, so E of x or mu, that's our mean. This is a different Greek letter. It stands for standard deviation. It's called sigma. And sigma is the standard deviation of a population. It's a measure of spread, so how spread out your data is. So variance and standard deviation are both kind of measures of spread. If we're talking a population, we use sigma. If we're talking a sample, which we'll get to in the data section, then a sample standard deviation is just a little f. And people use V or VAR for variance. And some people, instead of using the sigma, so in your notes, they kind of put both. They talked about standard deviation, STD, DEV, right? That's the same as sigma. And to find your sigma, you're always going to take the square root of your variance, okay? Square root of your variance. So there's lots of ways to calculate variance. And, it depends. Like some of you might be used to a certain method from high school. Me personally, I, do this kind of method in lots of courses. So I prefer, personally, to do my E of x squared minus the mean squared. They gave you this formula. This one, it's a little bit harder with the fractions sometimes. It's the sum of each number minus the mean. So this is take each number minus mean squared times the probability of each number, right? This one is we take, instead of E of x, we do the mean of the x squareds and then minus the answer we got to the mean squared. In this one, because you have to take every single number minus the mean squared times the probability, if the mean is a fraction or if your numbers are all fractions, it creates a lot of extra work. So that's the thing to keep in mind. Okay? But obviously I'll show you both and it's a personal choice, right? A question like that's never going to be a long answer, right? So it's going to be multiple choice. It's too easy to be a long answer. So here, our random variable x has values negative 1, 0, 1. Probability of negative 1 is 0. Probability of 0 is a half. And probability of 1 is a half. Find the mean and standard deviation. So the mean, or E of x, well, that's what we already did, right? We would just take each x times the probability. So negative 1 times 0 plus 0 times a half plus 1 times a half. That's a half. If I want E of x squared right here, then all I do is take my x column and just square them, right? So they're easy numbers to square. Negative 1 squared is positive 1, 0 squared is 0, 1 squared is 1. So E of x squared is just to take this column and multiply by this. So negative 1 times 1 probability times this. Circled the wrong one. So 0 times 1 plus a half times 0 plus a half times 1. So e of x squared, if e of x is x times probability, e of x squared is x squared times probabilities. So multiply them, 0 plus a half. And then the variance is just going to be your mean of the x squareds, which is a half, minus this mean squared. Always remember to square your mean. So a half minus a half squared is a half minus a quarter, which is a quarter. Our standard deviation then is the square root of our variance. And the square root of 1/4 is root 1 over root 4, or 1/2. So if you learned that formula in high school, then you're used to squaring your numbers, then you can use that, right? E of x squared minus mean squared. If you want to use this formula instead, then you're going to take every x value minus the mean squared times the probability. So you would take this first x, -1, minus the mean, so -1 minus a half squared, times, this is the probability of -1, right? Second x, 0, minus the mean is a half squared, times, and this is the probability that x is 0. And then this one, x is 1 minus a half squared, and this is the probability that x is 1. So you can see how it leads to a lot of fractions, and it is a lot more mental math, right? You can see how, this is a lot to simplify. Okay, so again, your choice, but if you are going to use this one and there are fractions involved, be super careful, right? Because it is very easy to make a mistake, especially on exams when we're stressed. More fractions generally equals more mistakes. Okay. All right, so the next part is switching now to continuous random variables. So no longer discrete, like things like a die, but now things like that are continuous. So, continuous random variables, we might be studying height or weight or distance, right? It's not like a dice where we can only roll 1, 2, 3, 4, 5, or 6. Now we've got, 2.65, 3.065, things like that. Okay. Now, remember I said they call it PMF in discrete instead of PDF for probability distribution function. This one we call PDF for probability density function. So when it's a density function, then that's going to be continuous, okay? So area is probability. So we still know that the total area under the graph has to be 1. We also know that our functions here have to be greater than or equal to 0, okay? So if you look at the graph, we can say, the graph can't be below the x-axis. That's what that f of x greater than or equal to 0 means, okay? We can't have the graph going under here. So you did a lot on the uniform distribution. The uniform is when it is a rectangle. So graphically, it just looks like, from some number to some number. The normal is the Z table. So some of you might have taken data in high school and used that table. We don't really use it in this course. We do talk about standardized values a little bit, but that's about it. It could be a triangle as well. If we have the area of a triangle, we know it's just base height over 2. So if we wanted to calculate, the area of this, we can just say, base of the triangle times height divided by 2. Area of a rectangle, we all remember, is length times width. These areas, we would have a table to look them up, okay? Keep in mind, for a discrete random variable like a die, the probability of rolling a 2 is 1/6, right? That's discrete. We know we can find the probability of, rolling a 2 is just one case. There's 1, 2 out of 6 numbers. But for continuous, the probability that x is equal to any number is 0. Because if we wanted the probability that x equals 0.6 here, there's no area to calculate, is there? It would have to be, between 0.6 and 0.7 or 0.6 and 0.61 or something. There has to be an area. Now, when we go to look at probability density functions, if we want to find the probability that we're between two numbers, that's really the integral. So from calc, where we learned all your integrals last semester, then we have the probability that x is between a and b is the integral from a to b of the function. Or in other words, fundamental theorem of calc, we did antiderivative at b minus antiderivative a. Okay, and I did put in here, your graph must be non-negative, means, not below the x-axis. Now, if you look at the whole integral from negative infinity up to infinity of the function, that has to be 1. Now, you don't have to do improper integrals. Remember in calc you had infinities, negative infinities. You're not going to have to do that in this course. But we do know that the total area has to be 1 under every graph. So if we think about the spread of a continuous graph, like the normal, so they talked, in your notes about thinking about the standard deviation variance and how you tell, which one is which. So, if a graph is sort of more flat like this here, then the standard deviation is larger because see how it's more spread out? Whereas this one, it's barely spread at all. So this has a much smaller standard deviation or variance. This one, the spread around the mean is much larger. So the larger standard deviation and variance is like more spread out, and closer together is a smaller standard deviation variance. The mean is just the middle where you've got a mirror image on each side. So this would have a mean of 2, this one would have a mean of negative 2, for example. Okay, so how does cumulative work with continuous versus we did discrete earlier? Well, the cumulative is the probability x is less or equal to x, right? The whole area below this number. And we represent the area as an integral. Now, the technical definition is, yes, negative infinity to x of f of t dt. But for you guys, it's only going to go from 0 to x. This can be any letter. You can use s, t, whatever. They used to use s, so it's a possibility that, this letter could be an s on some practice exams, okay? So it can technically be any letter. Just don't use x because that's the x. Okay, so this is the formula. This is to find capital F, which is the cumulative function. Okay, so to find capital F, we're going to take the integral. Okay, so that's from a PDF to a CDF, do the antiderivative. If we want to go the other way around, then we're going to do the derivative. So if we have capital F and we want little f, then we'll do the derivative. Okay, so from big F to little f would be do the derivative. So we're going to cover both in the practice. Now, for any cumulative distribution function, if you take the limit at the far right, as x approaches plus infinity, it's going to be 1. The limit of the far left, as you approach negative infinity, is going to be 0. Okay, and so, the graph has to start at 0 and keep going up until you eventually get to 1. Now, cumulative distribution functions will never decrease. They could stay the same for a bit at different x values, but they can't be decreasing. So they can't decrease anywhere. They also have to be right continuous. So as you approach from the right, the value of x has to be a solid circle, not open. So one time on an exam, they gave them 2 graphs. Well, they gave them 5 or whatever, but you could tell all of them apart except it was down to 2. And of the 2, people had trouble. And the only difference is that the points on some of them were solid versus open, okay? So as you approach from the right, the value must be a solid point. So I'll show you that in an example. So a specific type of continuous graph is, of course, the uniform, right? So I talked about how it looks like a rectangle. In terms of the cumulative, if we just look at the uniform graph from 0 to 1, then it's, 0 over here, and then between 0 and 1, it's just at a height of 1. Okay? So which of the following are probability density functions? Well, to be a PDF, think about what you need. We need the total area has to be 1, and we need that it's non-negative. So there's No part of the graph can be below the x-axis. Okay. So if they were to ask you a question on this, then we would check, is the area 1 and is it always, non-negative? Okay, so for the first one here, well, I've got, that's 16, and that's from 8 to 16. So guess what? That is not 1, is it? So clearly that can't be representing probability. So B, assuming the area is 1, then yes, right? If the area under this is 1, it's always above the x-axis, so that one's good. This one, well, it's perfectly symmetrical, so let's just do the area of 1/2 and double it. So the area of a triangle is base times height over 2, and then since there's 2 equal ones, we're going to times by 2. So base times height, well, from 0 to 1 is 1, and that's also 1. So 1 times 1 over 2 is 1/2 times 2 is 1. So that one's good. Yes, it can be a probability density function. It represents probability. What's wrong with D? What's wrong with D here? Anybody? Type it into your Q&A. Yeah, if it goes anywhere below, nope, can't represent probability. Awesome, good work. Okay, what about cumulative? Well, for cumulative functions, we need the limit as x approaches infinity. So the far right has to go to 1, and the far left has to go to 0. So let's see, this limit is 1, yes. So the limit x approaches infinity of the cumulative is 1, and the limit of the other side, x approaches negative infinity, is 0. This one's good. It's never decreasing, right? It doesn't have to increase everywhere, but it can't go back down. So that one's okay. B is kind of backwards, isn't it? Right? For B, the limit from the left is 1, and that doesn't make any sense. And we can see that it's decreasing. So that cannot represent probability. Cannot be a cumulative distribution function, right? Cumulative has to keep adding until you get up to 1. Okay. So C versus D. One of them's good, one of them's not. So take a look at C, and then take a look at D, and see if you can decide what you think here. So C is okay. So this one is open, and this one is colored in, right? Which means it's actually defined there at 1. So this is, what we call right continuous. So this is, yes, this one's good. The limit of x approaching infinity, this is 1, and it starts out here at 0, right? So the limit approaching positive infinity is 1, and the limit approaching negative infinity is 0. And it is colored in here. But for the last one, it's not. See how it's not right continuous? So this bar would have to be filled in for it to be representing a cumulative, okay? So we'd say not right continuous. So therefore, no, it's not correct. Okay, so we'll let you look at the other two later. So try these, and of course, you can ask me next class if you have any questions. So here we've got example 1. Let C greater than 0 be a constant, and let x be a continuous random variable with a probability density function. So here we read this question, we know it's continuous, so it's representing some graph. and it's representing probability. So see how this is a little f? That means this is a probability function, right? It's not continuous. Continuous would be not cumulative, sorry, wrong C word. It would be cumulative, it would have to be a capital F. Okay, so here we want to find capital F of x, which means find the cumulative, right? Find the cumulative distribution function. Okay, so let's see what they say. It says little f of x is 3x over c4 for 0 to c and 0 otherwise. So that means 0 otherwise just means there's no area anywhere else on the graph. The only area is from between 0 and c. So to find a cumulative, capital F, cumulative from a little f, we do the integral from 0 to x. We start at 0 because this starts at 0. Remember I said it won't really start at negative infinity for you guys. So it's from 0 to x of f of t dt or f of s ds, whatever letters you want to use. So we put the function in here. From here, 3x over c to the 4 just becomes 3t over c to the 4 because our x is there. So we can't use the same variable, it's just not proper, right? So if you did calc with me, I would often show you just to put the constants out in front and then integrate. So if you still prefer that, great. If you don't, you want to leave it all in, that's fine too. As long as you get the same final answer, it doesn't matter. So I'm going to put 3 over c4 in front so I can just kind of ignore it and then integrate this. And so the integral of t is like the integral of x, right? So x squared over 2, so this becomes t squared over 2 from 0 to x. So leave our constant, 3 over c4. And then from the fundamental theorem of calc from last semester, we sub the top number in for all the x's, or in this case for all the t's, minus sub the bottom number in for all the t's. So x squared over 2 minus 0 squared over 2, which is just 0. So we can just multiply those together, 3x squared over 2c4, or we can say 3 over 2c to the 4 times x squared. And that would be our cumulative function. Okay? Any questions? Okay. So let a greater than 0 be a constant. Let x be a continuous random variable associated with the probability density function here. Okay. So we've got little f of x, probability, not cumulative, right? So it's a4 minus x to the 4 if absolute value of x is less than a, and then it's 0 otherwise. So no area anywhere else, in other words, right? So if you think about, let's say you had absolute value of x is less than 3. Do you remember that that means that in terms of a number line, this is just kind of an aside, that any value that's negative 3 or all the way to positive 3, except not equal to the 3 or negative 3 would work. Because, if I put 0 in here, absolute value of 0 is 0, and 0 is less than 3. Put 1 in, 1 less than 3, yes. Absolute value of negative 1 is 1, and 1 is less than 3. So the absolute value of x less than 3 would be all the numbers between negative 3 and 3. So in general, for absolute value of x less than a is really just all the numbers between negative a and a. And we know, of course, that the total area has to be the total probability, which is 1, under any probability density function, right? So if we know the total area has to be 1, then we can set it up. The area from negative a to a, or the integral from negative a to a of a4 minus x to the 4 dx with respect to x has to be 1, right? And then we can just integrate. So remember, a is a number, right? Like 2, 3, 5. In my example, I just kind of made it up to be 3, but it could be any number. It says it's positive, right? So think about, if you had the integral of 2, it would be 2x. So the integral of 5 would be 5x. So it's kind of weird, but the integral of a to the 4 with respect to x is just a to the 4 times x, the constant times x. minus integral of x4 be x to the 5 over 5. So now you're done integrating. So top number subbed in for all the x's minus bottom number subbed in for all the x's, and then we can solve. So we've got a to the 4 times a minus a to the 5 over 5, and then here, a to the 4 times negative a minus negative a to the 5 over 5. So watch your signs just in case, right? So this would be a5 minus 1 over a5. So a to the 5 over 5, we could just say 1/5 a to the 5 like that. And then that's going to be plus a5. And that's negative, negative. And when I put this to the 5th power, well, negative 1 to the 5 is a negative. So it's 1, 2, 3 negative. So it's still minus 1 over 5 a to the 5. So in terms of, if you want, you can do it in 2 steps, add these up, or you can just throw a common denominator for all of it. Doesn't really matter as long as you get to the right answer. So that'd be 5 a to the 5 over 5 minus 1 a to the 5, and then times by 5 a to the 5 over 5, etc. So if I add it all up, I've got 5, 10 minus 2. So that's 8 a to the 5 over 5. I would just cross multiply. 8 a to the 5 is 5, and just divide both sides by 8. So final answer, you're trying to find a. So don't leave it as a 5th, right? Just take the 5th root. Or they could say to the 1/5, I guess. Sometimes, they write it like that instead. So 5 over 8 to the 1/5 would be correct as well. Okay. So that's our final. Any questions? Okay. So what if we want the mean or variance of a continuous random variable? Well, now we're going to use integrals, right? So instead of doing, each x value times the probability, we're going to use the mean, or e of x, is the integral, technically, from negative infinity to infinity of x f of x. So make sure you multiply your function, your probability function, by an x. But for you guys, of course, it won't have infinity or negative infinity on the integral. And don't forget, mean is also thought of as expected values. That's why we call it e of x sometimes. So for the purpose of this course, it's just going to be integral from a to b of x f of x. And the variance is, again, 2 different possibilities, right? So your choice. So you can do integral from a to b of x minus the mean squared times f of x. Or you can do, the e of x squared minus mean squared. E of x squared would be the integral from a to b of x squared f of x. So again, it's going to be your choice. So for this one here, it's piecewise, and there's 3 pieces here. So we have f of x is x between 0 and 1. F of x is 2 minus x between 1 and 2, and no area anywhere else. So if we want to find the probability that x is between -1 and 3, we would have to split it up according to this. So if we look at this, if you see how the x values are laid out, the lowest x value is really just going to start at 0. So from -1 to 3, if we look at from -1 to 0, it's just the function 0, right? So we can say the integral of 0, but it's just 0, so we technically don't need it. And then we have from 0 to 1, the integral would go from 0 to 1 of the function x dx. And then the last part is we want to go up to 3, and this, goes up to 2, right here. So from 1 to 2 here, so we would go So here I did from -1 to 0. So then from 0 to 1. Oh, so here I would have, let me type that in wrong. This should go from 1 to 2 then, right? And then the integral we could do from 2 to 3 would be 0. Like that. Okay, so this should go from 1 to 2. So switch that there. I'll have to fix that. And then we can, integrate them and solve. So these would be 0. Integral of x would be x to the 2 over 2. And integral of 2 minus x would be 2x minus x to the 2 over 2. And then we'd have to go from 1 to 2 there. Because I only made this go up to 2 here, not 3. Yeah. Okay. So that's how we'd find the probability. So write it out piecewise for all the different parts. Now, if you want the mean, we've got to do the mean for each piecewise part. So we have 2 parts plus the 0 part, which doesn't matter. So remember, the formula is x times f of x. So we do the integral from 0 to 1 of x, and then times the function. So this is f of x, and the formula is x f of x. And then here, that's our x, and then this is the function. So from 1 to 2, we do x times 2 minus x. So whenever you're doing e of x, you have to have x times the function as your formula. And again, it won't be negative infinity to infinity. It'll be whatever these piecewise functions are defined from. So this would be integral from 0 to 1 of x times x. Remember, you have to simplify before you integrate because there's no product or quotient rule for integrals, right? So x times x is x squared. Here, just multiply it out, 2x minus x squared. Then each of these integrate, right? Integral of x squared would be x3 over 3 from 0 to 1. And integral of 2x, well, technically it's 2x2 over 2, but they cancel, so it's really just x squared minus x3 over 3 from 1 to 2. Top number subbed in, so 1 to the 3 over 3 is 1/3, minus bottom number subbed in, 0 is just 0 cubed over 3 is still 0. And then here, same thing, 2 subbed in for all the x's minus 1 subbed in for all the x's. And lots of algebra, so common denominator, and, the mean ends up being exactly 1, okay? So here, this is like 4 over 1 minus 2 cubed. 2 times 2 times 2 is 8/3. This is minus 1 squared is minus 1, plus 1 cubed over 3 is 1/3. And then it's up to you. I did 4 minus 1 is 3, and then collected the fractions. -8 plus 1 is -7/3, and then I did my common denominator, but you could, by all means, just do it right here, too. Okay? So 9/3 minus 7/3 in the bracket is 2/3, plus 1/3 is an overall e of x is equal to exactly 1. Okay? All right, so take a break at 6:15. So come back at 6:30, go get some food, drinks, fresh air, whatever you need so you can focus. And we'll continue on this question, okay? I'll see you back shortly. and focus for a little while longer. I know it's hard with online sessions. So a few things, just a reminder, my email is in the front of the book. I think it's at the bottom of page 2. And of course you have that on-demand video that you can watch anytime from the midterm material. So obviously if you have a section that's really easy, you could try a few questions. Maybe you don't have to watch the video for that whole complete section, but just, see what you remember and, watch everything that you think you need to. And obviously try a few midterms in addition to all the finals in the supplement to make sure that you remember all the beginning stuff just as well, okay? I know there's always more on the final material on, since the midterm, but they're going to have stuff on the beginning as well, and you don't want to, forget to study it hard enough, okay? And as well, if you have anyone, friends who couldn't come tonight, you can tell them they can sign up and still come to part 2 tomorrow. And the video usually takes about 24 hours, so sometime during our session tomorrow night, then the video for tonight should be up, okay? All right, and also send me an email if you find any typos. So as I said, I had to rewrite tons and tons of questions, so I've corrected a couple things tonight, but if you find anything else where there's a number missing or a wrong number, then just send me an email and let me know so I can fix it in the online version right away, okay? Okay, so we'll continue on. So this was a multiple part. So we're still doing the same part, the question where we've got this piecewise, but we've got the mean, and now we're going to flip over to 184. So we knew that our E of x that we just did, or mu, was 1 from part B. So now we want the variance. So remember, the variance is going to be x squared times the function. So we have x squared f of x in each case. So from 0 to 1, the function is x. So it's from 0 to 1 integral x squared times the function. And then from 1 to 2, x squared times the function. And that whole thing is going to be e of x squared. So we multiply it out again. So x squared times x is x3. Here, 2x squared minus x cubed. Integrate x3, we get x4 over 4 from 0 to 1. Here we get 2x to the 3 over 3 minus integral of x3 is x4 over 4 from 1 to 2. We work all of that out. Again, same thing as always. Top number subbed in for the x's minus bottom number subbed in. Same thing here. Top number subbed in for all the x's minus, and then 1 subbed in for all the x's. And we get 7 over 6. So our variance is going to be our answer to e of x squared, which is the x squared times the f of x for each piecewise function, and then just minus our answer to part B, I guess, right? So from part B, we knew that the mean was 1. So it's 7 over 6 minus 1 squared, which is 7 over 6 minus 6 over 6, which is just 1/6. Okay, so that's our variance. If they wanted the standard deviation, by the way, sigma of x, then it would be square root of the b. And I guess, we could square root 1, so we could say 1 over root 6, right? Okay, so that would be the standard deviation. Okay, any questions? Okay. So the length of time needed by students in a particular course to complete a 1-hour exam is a random variable with PDF given by little f of x is k times x squared plus x from 0 to 1 and 0 everywhere else. So no area anywhere else. So A, for the random variable x, find the value of k that makes f of x a probability density function. B, find the cumulative distribution function. C, show that if you do the derivative of part B, you'll get the function in part A, and then we're going to do mean, variance, and standard deviation on the next page. So for part A here, if it's going to be a probability density function, think about what do you have to do for the integral there. We did one right at the start. So we're going to have to say that the integral from 0 to 1 of k times x squared plus x dx, the integral has to be 1. Because we know that the total area, which is the total probability, has to be 1. So if you want to put your k in front, great. If you don't, do whatever you want here. So take a minute, work this out, right? Do your integral. What would your k value be here? Okay, so we have k. Integral of x squared is x to the 3 over 3, plus integral of x is x squared over 2. So again, I can leave the k. So top number subbed in for all the x's would be 1 cubed is 1, so just be a third plus a half, minus, now just be 0 plus 0. And a third plus a half, we could say common denominator is 6, so 2 over 6 plus 3 over 6. And so it's like 5 over 6k. So if we cross multiply, since that equals 1, we could say, what, 5k is 6 and k is 6/5. So that is the number that we can put back in here, right? That k is 6/5 now. So part B, find the cumulative distribution function. So that's capital F. So may as well just put the 6/5 out in front. Remember, when you're doing a CDF, think about your integral, right? The integral for a CDF is always, from this smallest number, 0, up to x, right? It's always to x. And then you'll want to call these x's s or t or some other letter. So t squared plus t dt, something like that. Okay? So what do we get? Well, we integrate t squared plus t. So go ahead, write your answer for that here. So t to the 3 over 3 plus t squared over 2 from 0 up to x. So top number subbed in for x minus bottom number subbed in for x. And what do you get here? So it would be x to the 3 over 3 plus x squared over 2. And then it'd just be minus 0 plus 0. So we don't really need that, right? Now, it says show, that if you do the derivative of capital F of x, that you're going to get, our little f of x. Remember, to go from little f to big F, antiderivative, so backwards, from big F, we have to take the derivative of big F. So we do the derivative here. And of course, I can leave the constant in front. What's the derivative of x cubed over 3? Well, we can just leave the 1/3. Derivative of x cubed would be 3x squared plus a half. And derivative of x squared would be 2x. And so we get cancel, cancel, and 6/5 times x squared plus x, which is our little f. Okay, so find the mean on the next page. So think about, what's your formula for mean? What's your formula for mean? Well, if it's a continuous graph, we take the integral here from 0 to 1, and then remember, we have to take the f of x and multiply it by an x, right? So it's integral of x f of x. Okay, so if our function on the last page was 6/5 x squared plus x going from 0 to 1, what's your e of x going to be here? And once you get it, do the next couple steps. So it would be integral from 0 to 1. Throw the 6/5 out here if you want. And it's x times the function x squared plus x. So don't forget, we'd have to multiply it out first. So it'd be x cubed plus x squared under our integral. So what would you get when you integrate? I won't make you finish it right now, but what would your integral be? So it should be x4 over 4 plus x cubed over 3 from 0 to 1. So I'll let you finish that later. Try and finish it up. Final answer, so you know, should be 7/10. Okay, so 6/5 in front, brackets, top number subbed in for all the x's minus bottom number. Okay, subbed in for all the x's. So if we carry that our mean, or E of x, mu, or E of x is 7/10 over to part E on the next page. If we want to find our variance, then we're looking at E of x squared minus the mean squared. So our V of x is the integral from a to b of x squared f of x dx minus the mean squared, which was 7/10, right? So that's our formula for our V. So what is this? What is this E of x squared? Well, it's got to be the integral from 0 to 1. Again, if you want to put your 6/5 out in front, like me, you can. And now we have to take x squared times the function. Whereas for the mean, it was x times the function. So x squared times the function x squared plus x. Now, if you want to write this whole thing out each time and write minus and then square out the 7/10, you can. Or, you know, if you want to just do E of x squared and do this at the very end, it's kind of your choice. So this would be what? The integral from 0 to 1 of, so go ahead, multiply this out, and then go ahead and integrate. What would you get? So I'd have x4 plus x to the 3 dx. And so my mean, or E of x, if I integrate, then I'm hoping you said x5 over 5 plus x4 over 4 from 0 to 1. Okay, take a minute. What is that as a number answer? So this would be 6 over 5. This would be what? 1/5 plus 1/4 minus 0 plus 0 doesn't really matter. So common denominator of 20. So this one times by 4, 4 over 20. This fraction times by 5. So that's 6 over 5 times 9 over 20. Well, that's kind of nice, isn't it? Because it's 54 over 100. And then remember, our variance is that minus 7/10 squared. So that makes that really good, because 7/10 squared is also over 100. So 54 minus 49 over 100 would be 5 over 100, or 1/20. And that's our V. So what would your standard deviation be here then? we would do square root of the variance. So root of 1 over 20, or they might just say 1 over square root of 20, right? You could also, possibly rationalize that. I'm not sure if they would do it to you, but root 20, remember, is square root 4 times square root 5, and root 4 we can do in our head. So technically it could be 1 over 2 root 5. I mean, they could also multiply by root 5 over root 5 to get the root 5 off the bottom. I don't think they would do that, but possible. Okay, any questions? Okay, so you've got lots of practice with the mean, E of X, variance, standard deviation. So this one, I'll do part A with you, and I'll let you try the E of X after. Again, you can ask me tomorrow if you need help with it. So notice in this question that what we're given is capital F of X, right? So what does capital F of X represent? It represents that this is a cumulative function, right? Whereas the other ones were probability function, we were finding cumulative. So if we have the cumulative, we want to find little f of x, what do we have to do here, guys? Can you type it into your Q&A? What's our method to find little x, the probability function, based on the cumulative capital F of x? Yeah, that's right. We got to differentiate. We got to do the derivative, right? Before, to go from little f to big F was antiderivative, so now backwards is derivative. So we need the derivative with respect to x of this, right? Because this part of the cumulative is just the start of the graph is 0, and the end of the graph we know has to go up to 1. So the part with the function is just the derivative of x to the 4 over 4, or, the derivative of 1/4 x squared. So that would just be 2x over 4, or 1/2 x. Okay? And that's going to be your function that you're going to use to find your E of x. Okay? Question? Okay. So last one here. So example 6 on 189. So we've got our f of x here is x from 0 to 1, and it goes, our function is 2 minus x from 1 to 2, and 0 area anywhere else. So what if they ask you to find the probability that the absolute value of x is less than 3/2 here? So we know that, this function is piecewise. Probability is obviously area, right? We've got these two different lines, y equals x, y equals 2 minus x. And so one thing to notice is that absolute value of x less than 3/2, we talked about this earlier when I used -3, right? So in this case, it would go from -3/2 to +3/2. But look at your x's. No negatives, right? X only starts at 0. So there's no area below 0. So we can really just do from 0 to 3/2. Well, that means we can do the area under the graph. If we want to draw the graph, okay, sorry, coughing fit there. So we can do, if we go from 0 to 1, if x is 0 here, it's 0, and if x is 1, it's 1. So we get the line. And then here, if x goes from 1 to 2, if I put 1 in, 2 minus 1 is 1. 2 minus 1 1/2 would be 1/2, and 2 minus 2 is 0. So you can kind of see the two parts of the function there. And we're trying to find the area between negative 3/2 and 3/2, but there is no area over there, so it's just from 0 here. So you can do all kinds of things. You know, you could, of course, calculate the areas, 1, 2, and 3, right? So area of a triangle, another triangle, rectangle, you know, it's up to you. Or, of course, you can use the integrals. Okay? And you could also, instead of adding up all those areas, do this area and subtract from 1. Because the total area under any probability function should be 1. So if I do the area in here, this kind of orange triangle, I can do 1 minus that as the same yellow area that I want. So base, that's 1/2, and height was 3/2 gave us 1/2, right? So that's 1/2 times 1/2 over 2, 1/4 over 2, which is 1/8. And so we get area is 7/8. The other option is, of course, area 1 plus area 2 plus area 3. In terms of integrals, you could do from 0 to 3/2 here as from 0 to 1 plus from 1 to 3/2. By the way, it doesn't matter if you put equal to's on here or not, does it, right? Because remember, there's no area equal to this line, right? Area has to be between two numbers. From 0 to 1, we'd have the integral of x. And for the second part, we'd have the integral of 2 minus x. So that's another possibility. So there's lots of ways to do, you know, questions. You know, you can calculate the area from the graph, or you can use integrals. So it's ultimately up to you. Okay, long section, right? So the next couple are very short. So flip to section B. So there's tons of practice in A, just because there is, you know, lots of concepts in there, okay? Okay. So B is on page 194. So pseudo-random variables and simulation. So pseudo-random variables are used to generate numbers that are close to being random. So pseudo-random meaning not really exactly random. To generate like truly random numbers is very difficult. So pseudo means false. So in the sense, we're getting numbers that aren't really exactly random. If you put a number into a computer and use an algorithm, you can get an output. But if you use the same input number and the same output, like if you use the same input number and the same algorithm, you're going to get the same output every time, right? So there's a couple of videos I found, you know, if you're interested on using, you know, a random starting number or seed and how each seed gives you a new random number. In terms of test questions, if we, you know, use a computer to generate a string of numbers that can be used to model a random variable, if we're looking at the uniform random variable from 0 to 1, so I mentioned that at the very start of continuous, that f of x would be 1, and then from 0 to 1 and 0 otherwise, and that's what our graph looks like. And if we want to create a string of numbers that each look like it came from the uniform 0, 1 distribution, in other words, a is 0, b is 1, then we can use recursion. So we can say ut is a, ut minus 1 plus b. And what we do is we say, let U naught be some number C, and keep iterating forward. So remember when we did recursion for the midterm, we said we can get the third term from the second, fourth term using the third, etc. Okay? So we choose, these numbers, and for some choices of A, B, C, UT will grow without bound. So that we can control this, growing without bound, we use modulus, right? Mod numbers. So similar to having a clock and having your same position at AM and PM, but we don't use the integer 12, we're going to use modulus. So two integers are equivalent mod m if they have the same remainder when we divide by m. So what happens is, to work out mod, if we have ut is a ut minus 1 plus b mod m, and our first number u naught is c, then we can keep iterating, and if we keep doing so, we're going to get a good model of uniform random variables. Now, sometimes they'll ask you to find a function, and so in that case, we're going to have to find the inverse of the function. I'll show you that process. Okay, so this is kind of our process. Identify a mod distribution function, capital F of x, determine the inverse, which we call, of course, F inverse of x, which is calc from last semester, and generate a uniform random variable, random as in not exactly random, and then pass the number we get through step 3 through an inverse of a cumulative distribution function. So the gist of it is right here. We are going to have some positive integer a, non-negative integers b and c, and we're going to have this model. Ut is a times ut minus 1 plus b, mod m, with mu naught equals c. And so there's 3 styles of questions that I've seen on the exam. So one is, of course, just knowing how to work out mod, because we'll need to do that in the next question. So first of all, if you've never done any comp sci, then, the answer here is going to be the remainder when you divide the first number by the second number. If the second number happens to be larger, then the answer is just the first number listed before the mod. So here, if I want to do 9 mod 4, I do 9 divided by 4. Well, how many times does 4 go into 9? 2. But 2 times 4 is 8, so there's remainder 1. The answer is always your remainder. So the answer to 9 mod 4 is 1. If I want to do 18 mod 7, I take 18 divided by 7. So think about, what's that going to give us? Well, 2 sevens is 14. 14 plus what takes us to 18? Well, then that's going to be, I need 4 more. So our remainder is 4. So my answer to 18 mod 7 is the remainder, which is 4. This is an example where the second number is larger. So we would just say, by definition, this is just 4, okay? Because, 4 can't divide by 10, right? Okay, what would 45 mod 7 give you here? Well, 45 divided by 7 would be 6. 6 times 7 is 42. 42 plus 3. And 5 mod 6 would be what? Well, here we've got the second number larger, so we're just going to say that's 5. Okay. So second style of question on the exam. So ut is a ut minus 1 plus b mod m with u naught equals c. What are the first 3 numbers? So if a is 2, b is 1, c is 1, and m is 5. So that means if, t is 1, then what's U1? Think recursively, right? If I put a 1 in here, then A is 2. Let's put the A and B up in this function first. So A is 2, and B is 1, and it's mod 5. And my initial condition, U0, U0 is C, which is 1. Okay. So now if I do the first term here, U1 would be 2 U1 minus 1, so 2 U0 plus 1, and then mod 5. Okay. So, but U0 is 1, so put that in. 2 times 1 plus 1 mod 5. So that gives me 3 mod 5. Well, we just talked about that, right? So 3 mod 5 is just going to be 3, right? The second number larger. What about T2? Well, then put T is 2 back into the original up there. So U2 is 2, U2 minus 1, which is the term before, U1 plus 1, mod 5. Well, you know U1, so put it in recursively and see what you get here. So if this is 3, 2 times 3 plus 1 is what? 6 plus 1, so 7 mod 5. So work out what would 7 mod 5 be here. Well, 7 divided by 5 is going to be 1 with 2 left over, so that's going to be 2. So first term is 3, second term is 2. Oops, I meant that to say T equals 2. All right, so third, if T is 3, put 3 back into the original equation up here and write it out what it would be recursively here. So we'd have U3 is 2U2 plus 1 mod 5. And U2 is 2, so if we put that in, 2 times 2, so 4, plus 1 mod 5. Well, 5 mod 5, well, 5 divides by 5 once with the remainder 0. So that term would be 0. So the first 3 terms then would be 3, 2, 0 for part A. Okay, try part B on your own here. What would you get? Okay, so this would be, if my C is 2, that's my U naught is 2. So my formula would be UT is A, so 4, UT minus 1, plus B, so plus 4. So if I put U naught in, so U1 would be 4, U naught plus 4. And then it's mod M, so mod 3. So that would be 4 times U naught is 2 plus 4. So 4 times 2 is 8 plus 4, so 12 mod 3. Well, 12 divided by 3 is just going to be 4 with no remainder, right? So this is just going to be 0. Okay, because 12 divided by 3 is 4, remainder 0. So U2 is 4 times U1 plus 4 mod M mod 3. So if I put 0 in here, I get 4 times 0 plus 4 mod 3. So that's going to be 4 mod 3. So 4 divided by 3 is 1, remainder 0. So the remainder is 1. There's my first two. And last one, for U3, we'd have 4U2 plus 4 mod 3. And so if U2 is 1, that's 4 times 1 plus 4, so that's 8 mod 3. And 8 divided by 3 is 2 with remainder 2, so this is just going to be 2. So the three numbers would be 0, 1, 2. Okay. On the bottom here, in order to map UT to the interval 0, 1, so the uniform random variable between 0 and 1, you would always take UT and divide by M. So in part A, if our M is 5, we would be dividing it by 5. Now, the last type of question that they might ask on the exam would be this style. So suppose we've got a probability density function. F of x is a half x between -2 and 0, 0 otherwise. And we know this is a probability function, little f. So if we wish to generate a continuous random variable by passing uniform random variable on 0, 1 through a function, what function would we use? So when they ask that, 2 steps. Number 1, find your cumulative, and then find the inverse of the cumulative. So technically we know it's from -infinity to x, but it won't be. It'll be from the smallest number here, which usually is 0. But look, this graph goes from -2 up to something. So our integral has to start at -2 to x. And then the function is a half x. Remember, it's either a half t or a half s or whatever you're going to use. Remember, can't use x because the x is here. And keep in mind, normally in these questions, when it's not talking about a continuous random variable, right, pseudo-random variable questions, normally it starts at 0 and goes to something, so it's 0 to x. But in this case, it won't be because it starts at -2. So integrate a half t, or throw the half out in front, integrate t squared over 2 from -2 to x. So top number subbed in, which is x, so x squared over 2, minus bottom number subbed in for all the x's, so -2 squared over 2. So x squared over 2 minus 4 over 2. Don't forget, square negative is going to be positive. So I guess that function is, I mean, you could put the half through if you want. You could write it, this is like a half. We could say x squared minus 4 all over 2, or you could say that's x squared minus 4 over 4, I guess, right? So if that's your function, think of that like y equals. So do you remember in calc last semester to do the inverse? Do you remember we would switch x and y and then solve for y? So to find the inverse of this, I would say x is y squared minus 4 over 4. Cross multiply. So 4x equals y squared minus 4. I'm not sure why you mean subtract by 2. I didn't subtract. I subbed in the numbers. If this starts at negative 2, then instead of 0 to x, it's negative 2 to x. So this is just an integral, right? So I just said top number subbed in, fundamental theorem of calc, minus bottom number subbed in. So it's x squared minus negative 2 squared is positive 4. So it's x squared minus 4, and that's all over 2. Okay. So here, if we cross multiply, we get 4x is y squared minus 4, and I've got to solve this for y, right? So go ahead, what would y be? So here, well, we'd say 4x plus 4 is y squared. And so y, well, y is either the plus or minus root. But remember, this function here was in the negative, right? If we were to look at this graph, it's, in negative x's from negative 2 up to 0. So it's negative. So in this case, we would take negative of the square root of 4x plus 4. And so we could say, I guess we could take a 4 out as a common factor. So in terms of ways that they could mess with you, like let's say this answer wasn't on the exam, what could you do? You could take a 4 common factor out of these two terms and say 4 times x plus 1. And then you could say the root. Remember that the root of a times b is root a times root b. That works for products and quotients of roots. So we could, for example, say this is negative times root 4 times root x plus 1, or negative 2 root x plus 1. Okay, so don't forget, in the booklet, there's also lots of quiz questions. So from quizzes, and when I updated the final book, like I took out any questions that wouldn't apply based on what you did. Or, for example, when we get to like 3x3 inverse and determinants, if it was like, let's say a 3x3, then I would type in what the determinant was so that you could still figure out, if it's invertible, things like that. So there's quizzes throughout the book. There's also a practice exam on probability, on the midterm material that you can try. So things like that as well in your book. Okay, so the next section is also pretty short. So there's a quiz 4 there. You can try those. Also, good idea to redo your own quizzes before your final. So turn to 202. This section is really short. So in terms of questions on the exam, so for this section, sometimes they'll have a z-score, sometimes they'll have two different comparisons. Like one time it was like the speed of two different animals. So comparing them with z-scores, they could have the mean or the standard deviation of a set of a couple of values. Of course, they have to keep it fairly simple just because of, no calculator. And they could have, you find the t. Yeah. Okay, so 202. The mean of numbers, if you just have, some marks, this kind of data type question, well, we know from high school, if we wanted the average, we would just add up all our marks and just divide by how many there were, right? So that's the sum of all the x's over n. So n is the number of data. So if you have marks and there's 5 marks, then n is 5, for example. Okay. The standard deviation in the context of, if you've got a couple numbers given to you, you would take the sum of xi minus x bar squared. That means you take each number minus the mean squared. And if it's a sample standard deviation, you're going to divide by n minus 1. Okay, and again, n is your number of data. And if you look at S, that's the sample standard deviation. S squared would be the sample variance, right? We know that the population variance would be sigma squared, so S squared is going to be the sample standard deviation. S squared is the sample variance, sorry, and S is the sample standard deviation. So what's the range of what S can be? Well, if your data is not spread out at all, then S could be 0. It can't be negative, so the smallest is 0. So for example, if all my numbers were 4, how spread out are these around the mean? Well, the mean would be 4, and the standard deviation would be 0, because they're not spread out at all, right? If we had numbers like 4, 5, 6, 7, that would be a pretty small standard deviation. But if we had numbers that were like 10, 100, 1,000, 2,000, then they're really spread out, the standard deviation would be really huge. Okay? Standard deviation would always have the same units as whatever your original data. And of course, as the data gets more spread out around the mean, then the standard deviation and the variance would get larger. So generally, in most courses, we would say Z is X minus mu over sigma. But here, since we're talking about samples, if we want to look at the Z score or the normalized result, it gives us something like a relative standing or a standardized value. So the Z score, which again, if we had the Z table, we could look it up and find an actual percentage, but you don't have to do that in this course, but you might have to do it, in a stats course sometime. So if you take biostats, then you'll get out of using the Z table, but if you take a different stats next year, then you might have to use the table. So X is your observation. So let's say your mark. And then minus X bar would be the mean, or the average mark, let's say on a test. So X is like your mark, right? And then S is the standard deviation of that sample. So you do your mark minus the mean mark all over the standard deviation. And the larger that is, the more, further away you are from the mean. If it's positive, then obviously you did better than the mean. If it's a negative Z score, then your mark is less or worse than the mean kind of thing. Okay? So the larger the number of standard deviations from the mean, the more extreme result. So a positive, if you think about the normal, if the mean is 0 of the normal distribution, then that's 1 standard deviation, right? So that's Z is -1 to Z is +1. And as you keep going out, you get further and further. So both -1 and 1 are the same distance from the mean. They're just in opposite direction. So +1 is 1 standard deviation above the mean, whereas -1 is 1 standard deviation below the mean. Okay.